for having me again this year. It's always a pleasure to come all the way out here from the UK, from Berlin, all the way to China, to get a bit of a feeling what the community here feels, what enterprises are looking at when they talk about blockchain. I'm Bjorn. I'm one of the co-founders of Parity Technologies and mostly look after our commercialization strategy and products. And for those of you that might know us, you probably know us from our former flagship product, which was the Parity Ethereum client, which from its origins 2 years ago to today has grown into the piece of software that powers the majority of businesses that want to interact with the public Ethereum network, as well as powering dozens of enterprise networks, permission enterprise networks based on Ethereum technology. From being founded 3 years ago to today, we have grown to a team of over 60 researchers and developers that are experts in blockchain technology, obviously, but as well as more generally systems programming, cryptography, and distributed systems in general. And while Parity Ethereum is worthwhile talking about it for ages, I want to take the time today and talk about the new products that we've been busy building over the past year and that we will put more and more effort into over the next years. And that is namely Polkadot and Parity Substrate, which from our perspective is a new foundation for blockchain innovators. So let me take a few minutes to set the stage, to give you a bit of introduction, to understand what I will be getting into over the next 20 minutes. Critically, blockchain has two core parts, in my opinion. Two parts that we are really interested in, why there's such a hype about blockchain in general. These two parts are, number one, consensus, right? This part, this building block of blockchain software that allows us to agree on changes, to come to consensus, right? And there are different algorithms, and I don't want to go into detail. We've all heard about PBFD, Algorand, and some other consensus algorithms. But the other part around consensus engines or consensus mechanisms that we are interested in is the incentives. The incentive that lets us assume that there is an honest majority coming to consensus, right? And this part is more like the proof of work part, the proof of stake part, which provides incentive for the consensus algorithm. The other very critical part in blockchain software is the state machine. And to understand what the state machine is, I want to give you two examples, right? If you look at Bitcoin, the state machine is fairly simple, you could say. It really turns around providing rules that allow you to have more or less an accounting system where you can send tokens from one account to another. And it does that pretty well, right? It's constrained in what it can, but it does that specific thing pretty well. Whereas in Ethereum, you have Ethereum provides you with a much more general, much more open and Turing-complete scripting language that allows you to build these decentralized applications that we've been all so excited about these past years. And I mean, you might be able to take a bit away from this diagram where you have a state on the left side, the previous state. You have some rules that define the state transition. So what happens if you have some kind of input coming from outside the system, like a signed transaction into the system, and how the state changes from the left side to the right side. So why did we bother saying like, hey, we want to start a new protocol, right? Why did we say there are other ideas floating around in the space that we really want to pursue that are worthwhile exploring? One thing that has become very obvious, very apparent over the last few years is that one size doesn't fit all, right? Like we've seen an explosion in the number of different blockchain technologies. And we've seen that different projects really have different needs in terms of the design of the platform that you want to build on, and especially with regard to the state machine design. To give you one tangible example, right? The enterprise space. We as Parity Technologies have been engaging in enterprise POCs, in production systems over the past few years, and I think there are roughly 2 to 3 dozen Parity Ethereum production systems running in enterprise that I'm aware of right now. And what has become apparent in these projects is that, for example, permissioning confidentiality requirements that businesses have can't be met in public blockchains today, right? In current generation blockchains, as you all know. And that's why these enterprises turn to, hey, you know, we're still very excited about the prospects of what this technology can potentially give us. And, you know, we will just use it initially in a more secure environment, in a consortium environment, in a more permissioned environment. But that again, right, pursuing these ideas and pursuing this road really results in business turning to isolated private chains. And what we end up with is, again, a fragmented landscape. The very fragmented landscape, the very data silos that blockchain actually promised to break out of. So that's not really the road we want to go down, right? So what has become clear and apparent is the need for interoperability, right? These blockchains, these different state machines, these different designs of systems need to be able to talk to each other and critically understand each other. Welcome to Polkadot. So to have it not as abstract of a thing when you talk about interoperability, I want to take 1 or 2 minutes to walk you through what we understand on a full, like real interoperability. So real interoperability, in my understanding, is a system that allows you to connecting chains with distinct state machines and distinct consensus. Interoperability should mean that this system, this very general system that you build, allows to cater for the past, the present, and the future. And what I mean by that is that it should allow you, when you're part of this network, part of this new framework and network, you should be able to access assets that live on like past generation blockchains, such as Bitcoin, or such as Dogecoin, or such as Zcash, right? At the same time, this framework should be as open in general to be able to annihilate, to really absorb new technology that's coming, right? New advancements in cryptography, such as zero-knowledge proof, and so forth. The other critical thing that I believe is absolutely needed today is that we need a public network that allows you, right, to have private, permissioned, and more public chains, unpermissioned chains, to live within the same framework and network and to talk to each other. So think of, for example, your consortium chain, right? You have a banking consortium in China that has some blockchain infrastructure. You have some engineering company that powers its supply chain with blockchain, and you have a permissionless payment blockchain, such as, let's say, Zcash or Bitcoin. Those should be interoperable by design within that system. They should be able to talk to each other and be connected in whatever way you want, right? So for example, some certain delivery should be able to kick off a payment on this permissionless chain. So, but interoperability is a lot more than just token transfers between chains, right? Interoperability of tokens is clearly desirable and a big deal, right? Just think of decentralized exchanges that allow you to exchange tokens across different chains. But what we believe, what is way more powerful, is arbitrary message passing, which really is a superset of just token interoperability. To be a bit more clear on that front, right? What interoperability means, what arbitrary message passing means. It's basically
you would have one chain that could be a special purpose chain for a highly encrypted, high performance trading chain that can shoot a message over to another chain and like kick off a contract, like on the Ethereum chain, right? That is arbitrary message passing. You can really relay whatever information you want and thereby kind of split up your business logic across multiple chains if you want to. The other critical part in Polkadot is that we're trying to co-secure the community, right? So interoperability is already hard, right? But what is even harder is to make sure that all these chains that you're trying to connect, that you're trying to enable to talk to each other, are all secure, So, why is that important? Well, let's say you have chain A, you have chain B, and chain A is only a bit secure, and chain B is very secure. Now, if you enable these to talk to each other, and if some business logic on chain B is dependent on actions on chain A, right? If chain A is compromised, suddenly all of the chains are compromised. That is why we believe we need a mechanism that secures all of them in the most secure possible, most secure way possible. So, to double down on that, traditionally, what we've seen in blockchains is that when you have a good idea, if you want to spin up a new blockchain protocol, you compete for these resources that secure your chain. On the left side here, you can see that in the example of proof of work. Bitcoin competes potentially with Ethereum for mining. That's not quite true because, Ethereum is secured by GPUs, whereas today Bitcoin is secured much more by ASICs, but in general it's true. So if you look at all the GPU secured blockchains, they all compete for the same hardware. And this hardware, right, where you focus, where you turn your mining hardware on what blockchain, really leads to a situation where each of these chains is less secure as more chains pop up, right? Whereas, and in proof of stake you have the same situation, right? You have a limited amount of resources, a limited amount of money that you can stake towards chains. So, if there are 10 chains you're interested in, or 10 chains that people are interested in, these resources will be split up and each of these chains will be less secure. What we believe we can achieve with Polkadot is that we share the security, so that all the chains that are part of the Polkadot network are being provided with the finalization, the consensus mechanism. All of them get the power of all the resources pooled together. And that really sets Polkadot apart from all the other proposals that are out there. All the other interoperability multi-chain proposals. The distinct difference. And there's a really nice side effect of that, right? When you get interoperability between these very different things that run in parallel, these different chains, these different state machines, what you actually get is scalability. You scale blockchain horizontally. You increase throughput by having the possibility of having multiple things in parallel on different chains in parallel. So, here's a diagram that gives you a 10,000-foot overview of Polkadot, right? We have a power chain. We have many parachains, right? These are the chains that can be very different in nature. They can look like Zcash, they can look like Bitcoin, they can look like Ethereum, they can look like something crazy new that has some completely different data structure than what you're used of from blockchains. They can be permissioned enterprise networks, whatever you want pretty much. And we have a relay chain, and the relay chain is the beacon chain, the overarching beacon chain that allows these parachains to communicate with each other and that secures all of these parachains in parallel. And last but not least, we have bridges that kind of link these, current and past generations blockchains together, such as Ethereum and Bitcoin, and make sure that from within the Polkadot network you can access these assets as well. Now, how do you build parachains, right? That's a good question. Well, what we've done at Parity Technologies over the past month is we've developed a framework, so to say an SDK, that makes it extremely easy for you to build new blockchains. Right, initially, these can be standalone, independent blockchains, right? They can have their own validator set, their own consensus. They can run in a more permission setting or in a permissionless setting, whatever you want. But the idea behind this is that when you build on Substrate today, when you build your blockchain on Substrate today, you can port it over tomorrow and be part of the Polkadot network once it launches. So Parity Substrate really is a set of libraries. It's a framework to create blockchains. And we've taken all our learnings, all our experience from building the Bitcoin client, the Ethereum client, from looking into the Zcash client, into building a whole new set of libraries that make us easier and have a few distinct properties that we believe are very powerful. So one of them is that we started from the ground up. We thought of, hey, we need first-class light clients within that design, right? We all know it's not reasonable to assume that in the long run, users will run full nodes. They are way too resource intense, and we've seen what's happening in Ethereum currently, that less and less people run full nodes, and it's becoming harder and harder. So we have first-class light clients. The other thing that we have pioneered, and to my knowledge it's been the first instant that that has happened in the blockchain space, is we had an on-chain runtime upgrade. So what we could do is we could upgrade the Polkadot protocol without having to upgrade all the software, without users having to upgrade their software. That means you don't have any accidental hard forks anymore. This is super interesting. So to give you a quick overview of what Substrate looks like, there are roughly 4 components you should know about. On the bottom layer, we have Lib2P, the networking part of the stack, right? As well as the consensus part. We have implemented a few different consensus mechanisms that will be available in the Substrate framework. One of them is something you're probably well aware of. It's PDFT, a PDFT-like consensus mechanism. The other one will be a hybrid consensus that is really a next generation consensus and allows kind of caters for the trade-off of having like a really lively consensus algorithm and at the same time having absolute finality as you want in BFT systems. So as well, you have the WebAssembly execution environment, and within the WebAssembly execution environment is the runtime. And the runtime is really what you're interested in because it defines what your blockchain does, what it provides you with. And all the bottom parts we've implemented in Rust. They are being compiled to native code that runs incredibly fast. And the top part, the runtime, right, that includes governance, DAO, staking, slashing, whatever you want, right, is we have written in Rust, but you compile it down to WASM and native, right, code. And that really allows you to have this on-chain upgrade. So where do we stand today? POC 1 was published earlier in spring this year. POC 2 was published a few months ago. We have a live and running testnet that already proves how co-finalization of these non-communicating parachains work and a basic lifetime. Within the next month, I believe we will publish the next POC 3. This POC 3 will also include the new hybrid consensus that I think is super interesting. And then POC 4 and onwards will prove other points until we will launch in roughly around 1 year. This is the Polkadot roadmap. Substrate. Well, Substrate is in a state where you can use it now. So the 1.0 release is upcoming. It will probably be only like 2 or 3 weeks, maybe 4 weeks until we release it. And I highly invite you to get in touch with us, to look into it, and really innovate in the blockchain space. The last minute I want to use to do a call for contributors, right? We, Parity Technologies, as well as the Web3 Foundation, who is shepherding this whole Web3 vision and funding the effort, the Polkadot effort, are looking for researchers, parachain implementer, educators, communicators, and so forth. As well as obviously enterprises that are eager to really use cutting-edge technology. Here are a few links that you can check out. Please get in touch with me. I will be around for another 1 or 2 days, so let's take the time and innovate. Thank you so much.